Okay, so the next topic on our list of things to talk about are the hurdles we come up against when delving into hybrid computing, right here. Now the next chart you're going to see is going to be this branch of our tree, right here, the green part, organized into a more detailed manner. So we're going to have some of them split into multiple subdivisions, and then some of these are going to be grouped into a larger overall category. Now this tree shows all of the areas of hybrid computing which need to be further developed or improved upon. This tree is broken down into three main sections. We have the GPU programming language complexity, hardware limits, and then the heterogeneity problems. In the end, this would be a good place for anyone doing research on or thesis on GPU hybrid programming to start if you're really unfamiliar with this topic. It gives you a good, well-rounded understanding of the issues we currently face today, and after discussing the hurdles in hybrid computing, we're then going to talk about the research and the work that's accomplished thus far, so get you up to speed on what's been done so far, what's been accomplished, and what still needs to be accomplished. So what are some of the hurdles in hybrid CPU-GPU computing? Data transfer bottlenecks is one of the main hurdles that we need to overcome to progress hybrid computing. Information travels quite rapidly within a single processor chip, but then once data needs to be transferred via copper cabling to another chip, you really start to see data bottlenecks. The main hardware limitations in hybrid computing is this significant overhead when it comes to memory transfer between the host CPU and the GPU. Another thing is that parallel programming concepts are another big hurdle. This type of computing is difficult many times a difficulty many times in any type of computing, whether you're talking about GPU computing or CPU computing. Multiprocessor chip hardware requires dauntingly compact software that code that breaks up the computing chores into simultaneously processed chunks of code. And orchestrating these events accordingly can be a really difficult task and time, to say the least. Now, of course, then we talked earlier about the GPU versus CPU battles. In the past few years, we've started seeing public battles and bickering between the CPU and GPU industries. On top of everything already mentioned, we have the complexity of current GPU programming languages. GPU programming, such as CUDA, is fairly new, and for this reason, there is still a fair amount of complexity involved in the GPU programming. For some, GPU programming can be seen as fairly complex and error-prone. Optimizing an algorithm for specific GPUs is a time-consuming task which currently requires thorough knowledge of both algorithms as well as the hardware. When it comes down to it, programmers should not have to concern themselves with the intricate details of the hardware. Everybody would agree that programmers should have a general knowledge of the hardware, but even if you're a software developer or the hardware programmers themselves, but GPU programming sometimes takes an understanding and knowledge of the intricate details of the hardware. There's also the concern about the lack of portability, which can be achieved with current GPU programming languages. GPU code really does currently lack the portability due to the fact that the code for one GPU may not run as efficiently or at all when run on a non-native GPU hardware. Much of the GPU coding is not even capable of being efficiently ported over to different generations and or models of the same exact GPU brands. There's also a desire for GPU code to be able to fall back and run on CPUs if the GPU is not available, and this feature is only seen in a few GPU APIs so far. Lastly, there's the complexity of hybrid optimization, which is another hurdle which will need to be tackled. There's been entire theses done on GPU CPU communication optimization, and there's still a lot of work left that needs to be done in this area of study.